Hello, we're going to talk about intensity. The symbol is I, and it's defined as power divided by the area. So area, we're just going to say it's A. Yeah, so we don't need the delta here. So the unit is watts per meter square. So if we consider a light source, this is a light source here. And then you have the sphere. So this is a 3D sphere. Okay, so we didn't draw it, but this is a 3D sphere with R1 and R2 radius. And they have a different surface area at here and here. And they are 4 pi R1 square, according to the formula for sphere, surface area for sphere. And you have 4 pi R2 square. So if you know the power of this light source is P. So this P is a light source here. So P here is the light source power. So then I1 intensity at this R1 surface area will be P divided by the area, which is 4 pi R1 square. So as the R square increase from R1 to R2, then you can see I2 is reducing, I is reducing, and as the R square is increasing. Okay. All right. So next, we consider EM wave with electric field and magnetic field B. They are perpendicular. And then you'll see it's also perpendicular to E and B. So the 3 of them are mutually perpendicular, like we discussed before. So now it's moving toward this direction. So we're considering this delta V here. So this delta V, I'm getting the color here. This delta V right here, this delta V, I don't know why I'm not getting the color. Okay, this delta V is A times the delta X. Okay, so A times delta X, the delta X is the speed of light. Delta X is speed of light times the delta T. So that's how much the light will travel in the delta T time. So we consider this delta V here. So we're saying in delta T, the light will be able to passing through this area times this thickness. So that would be this delta V. So we know the energy per unit volume. This is energy per unit volume from before. Energy, right, per unit volume, right? Okay, so we times the delta T back, then this is the energy in the volume delta V, which is delta capital U. So we just going to recall this energy, unit density, unit volume energy, right? So energy by per unit volume is epsilon zero. Epsilon zero is permittivity times E squared. So you put that in, and delta V is equal to A times delta X, which is A delta X is C delta T. So we're going to put that right here. So now we're going to calculate the I in this kind of situation. And the I is going to be equal to delta U delta T. This is the power, right? So on the top here, this is the power right there. On the numerator, that's your power right there. And the power divided by A is your I, like here, right? Power divided by A, area is the I. So then we're going to look at this formula here, and you're going to A delta T divided by A delta T, right? Delta T move down here. So this will be A delta T cancel out, then will be epsilon zero E squared times C. Epsilon zero E squared times C. Okay, so that is the concept of intensity for our EM wave. And we're going to stop right there. Yeah. Bye bye now.